We have two spheres. The first sphere here has a radius r1 and the second sphere has a radius r2. The formula for the volume of the sphere for the first sphere is 4 divided by 3 times pi times the radius r1 raised to the power of 3, and similarly we write the formula for the volume of the second sphere. Now what we want to do is to compare the volumes, taking that R2 is a multiple of R1, k times R1, where k is a positive integer. So we take the ratio V1 divided by V2, we substitute the formulas for the volumes, now we can simplify these numbers in the numerator and in the denominator. So we have R1 to the third power divided by R2 to the third power. But we know that R2 is k times R1 and all raised to the third power. So the denominator is k to the power of 3, R1 to the power of 3. We simplify and we have that V1 divided by V2 equals 1 over k to the power of 3. So the volume V2 equals k to the power of 3 V1. Which means that if I tune the radius, if I increase the radius of the second sphere as a multiple of the radius of the first sphere, I have that the volume of the second sphere will be a constant k to the power of 3 times V1. V2 equals k to the power of 3 V1. So if the radius of the second sphere, if R2 equals to R1, if I double the radius, V2 should be, so here k equals 2, V2 should be 2 to the power of 3 V1. V2 equals 8 V1. R2 equals 3 R1, k here equals 3, R2, the volume V2 should be what? The volume V2 should be k to the power of 3 times V1, 3 to the power of 3 V1 equals 27 V1. V2 equals 27 V1. This is a nice exercise because we see that if you tune the radius, if you increase the radius compared to the previous one, then you increase the volume of the sphere. Here we have two spheres. The radius of the first sphere is R1 and the radius is R2, written as k times R1. And we want to compare the volumes, so we divide them. And we obtain that V2, the volume of the second sphere, is a constant times the volume of the first sphere. And we see that here, if the radius of the second sphere is twice the radius of the first sphere, we have that the volume of the second sphere is 8 times the volume of the first sphere. And if we increase k, if we triple this 3 times the radius of the first sphere, we get that the volume of the second sphere is 27 times the volume of the first sphere. It's a really nice problem.